Let's take a look at this example. Again, we're supposed to look for the quantities which we're supposed to find. Okay, so find. We have to find P total. Okay, see the arrow over here? We're supposed to find, this is going to be my I total. Okay, we have to find P1, and we're supposed to find I23, because this current is going to split into two currents. I call this IR23. We're supposed to find P2, and we're supposed to find also P3. Okay, so how are we supposed to approach this problem? How I would solve this problem? So first of all, please realize that we have given voltage source. We have given all resistances. So keep in mind that we can find the let's say currents. Okay, so I have R1 is equal V1 over R1. We have 100 volts divided by R1, which is equal 1.1 kilo ohms, and this is equal 100 divided by 1.1 exponent 3 is equal 90.9 milliamps. 90.9 milliamps. Next, I can find IR2. Okay, so let me put camera over here, and IR2 is equal V1 or VR2 over R2. VR2 is equal 100 volts. Let me remind you one more time. This is KVL for parallel circuit. V1, which is your voltage source, is equal to VR1. This is also equal to VR2. This is equal VR3. That's why I keep writing 100 volts every time I see voltage. Okay, so I have divided by R2, which is equal 5.6 kilo ohms. This is equal 100 divided by 5.6 exponent 3 equals 17.85 milliamps. Okay, so this is the current which will go through resistor R2. Next, I'm supposed to find the current which goes through resistor R3. So I have R3 is equal VR3 over R3. VR3 is equal 100 volts, of course, divided by R3, which is equal 12 kilo ohms. So this is equal 100 divided by 12 exponent 3 equals 8.33 milliamps. 8.33 milliamps. Okay, so we found these three currents. Okay, so let me remind you, this is my I total, and this is my current IR23. Okay, in order to find this current, I'm supposed to add these two currents, because this current is the sum of these two currents. So let me write this down. IR23 is equal IR2 plus IR3. IR2 is equal 17.85 milliamps plus IR3, which is equal 8.33 milliamps. Okay, we have to add them up, and let's see what we'll have. We have 17.85 exponent 3 negative plus 8.33 exponent 3 negative equals 26.18 milliamps. Okay, so this is my current IR23. Okay, so this is the current which we're supposed to find. Now I can find I total. I total is equal IR1 plus IR23. Okay, so this current plus this current, okay, the sum of these two currents will give me this current. Okay, so IR1 we found is equal 90.9 milliamps, okay, plus IR2 which is equal 26.18 milliamps, and this is equal 90.9 exponent 3 negative plus 26.18 exponent 3 negative. This is equal 117.08 milliamps. Okay, so this is the value of my total current. Okay, so next we're supposed to find P total. Okay, because we found I total, we found IR23, we found also the voltages, right? So now we can find P total. P total is equal voltage source, which is V1, times I total. So V1 is equal 100 volts times I total, which is equal 117.08 milliamps. This is equal 100 times 117.08 exponent 3 negative, and this is equal 11.7 watts. 11.7 watts. Okay, we got 11.7 watts for P total. Next, we can find the powers at each resistors. Because voltage is given and resistances are given, I'm going to use the values which were given. Okay, so if I made mistake with finding currents, for example, and I'm going to use these quantities to find the power, I can have also power wrong. So keep in mind always, if this is possible, use the values which were given as the first. If you have no other option, use the ones which you obtain from the calculations. So because I have voltage given and resistance given, I'm going to use the formula for power, which contains voltage and resistance. Power is equal to voltage square over resistance. So if I want to find the power, I simply write that this is P1 is equal VR1 to the second power over resistor R1. Okay, so this is equal VR1 100 volts to the second power over R1 1.1 kilo ohms is equal 100 square divided by 1.1 exponent 3 equals 9.09 watts. Okay, so this is the current, this is the power for resistor 1. P2 P2 is equal VR2 to the second power over R2, which is equal 100 volts to the second power over 5.6 kiloohms. Okay, so this is equal 100 squared divided by 5.6 exponent 3 is equal 1.78 watts. 1.78 watts. Okay. Next one, we're supposed to find P3. P3 is equal VR3 to the second power over R3. Okay, so this is equal 100 volts to the second power divided by R3, which is equal 12 kiloohms. So this is equal 100 squared divided by 12 exponent 3 equals 833.33 milliwatts. 833.33 milliwatts. Okay, so this is the power for resistor P3. Next, I'm supposed to verify my answers. How I can do that? Simply find the power, total power, in a little bit different way. P total is equal P1 plus P2 plus P3. Okay, so I have P1 is equal 9.09 watts plus P2 is equal 1.78 watts plus P3 833.33 milliwatts. Okay, this is equal P total equals. So let's calculate it. So I have 9.09, okay, plus 1.78 plus 833.33 exponent 3 negative equals 11.7 watts. I got 11.7 watts. Please notice that we get the same value of the power, okay, using two different techniques. So we found everything and we proved that our answers are correct. So we can say that the problem is solved.